Hi, everyone. My name is Katy Sadowski, and I'm on the real-world evidence team at Boehringer Ingelheim. Today, I'm going to be giving a demo of some new data quality features we've added into dbt Cynthia, which is an open source OMOP ETL project. Before I dive into the demo, I want to say a big thank you to my co-authors, Lawrence Adams and Thomas Wiley. And I also have a couple of background slides to share that'll help contextualize the demo. First things first, what is data quality? In OHDSI, we define data quality as the state of completeness, validity, consistency, timeliness, and accuracy that makes data appropriate for a specific use. So for any given data use case, there's a level of each of these parameters that will allow us to consider a data set to be of sufficient quality to successfully support that use case. When we measure data quality, we're essentially measuring the fidelity of a data set to the true patient experience and the patient's actual state of health in the real world. That fidelity can be compromised in two major ways. One, when the data is originally recorded in whatever source system we're getting our data from. So, for example, patient information is entered into an EHR system or an insurance claim is filed for a medical procedure. The gap between what actually happened in the clinic and what ends up in these systems is what most people are referring to when they talk about data quality and observational research. Things like data entry errors, upcoding, copy forward duplication, working diagnoses, broken integrations, so many things can impact the quality of a healthcare data set. The second major source of data quality issues arises when that data is extracted from the source system for secondary use, and ultimately, in the case of OHDSI, ending up in our OMOP CDM. So there's a lot of manual and programmatic steps that need to happen to map a source data set into the OMOP CDM. And because humans are performing these tasks and humans are writing the code to accomplish them, there's naturally a lot of room for error. And it's this second type of data quality issue that's the focus of my demo today. Quick terminology sidebar. This term ETL stands for extract, transform, load. And in OHDSI, we use this term to refer to the process of transforming a source data set into the OMOP CDM. The main tool that exists in OHDSI today to help us identify and address data quality issues is called Data Quality Dashboard, or DQD. DQD is an R package that runs thousands of checks on all of those aspects of data quality I mentioned earlier. And the traditional workflow is to write your ETL code, run the ETL to produce an OMOP CDM, and then run the data quality dashboard on the CDM. So DQD does a great job of both characterizing those inherent data quality issues coming from the source, as well as revealing issues caused by errors in the ETL code. So there's often this iterative process of running the ETL, finding issues in DQD, updating the ETL, rerunning the ETL, rerunning DQD, and so on. You can imagine this process can be pretty onerous, especially with a complex ETL that might take hours to execute each time and might have taken hundreds or even thousands of hours to design and implement in the first place. So the solution I'm proposing is that we move all of these data quality checks into the ETL pipeline itself so that developers can detect and resolve issues in real time as the ETL code is being written. Thankfully, we didn't need to figure out how to do this all on our own. There is a software solution which was built with this exact challenge in mind. That software is called dbt. dbt is an open source data transformation framework that can be used to implement an OMOP ETL or any other type of data transformation. So over the past 10 years or so, it's grown to become an industry standard for data transformation across all of tech, and it's actually growing in popularity in the medical field as well. And it's got a ton of great features that make it easy to maintain, test, and document an ETL pipeline. And best of all, it's an open source technology, so the core dbt engine is completely free to use. So just going back to my title slide for a second, hopefully this should all make a lot more sense now. In my demo, I'm going to show you how we can use dbt, an open source data transformation tool, to test data quality as we extract, transform, and load a source data set into the OMOP CDM. I'm going to stop sharing this screen and pull up my code. Can you see my screen again?
Yes.
Wonderful. So this is the code repository for dbt Cynthia, which is a demo ETL implemented using dbt. This project's also completely open source, and you can find it on the OHDSI GitHub. And right now, I have this ETL hooked up to a small synthetic database, which is also itself available in that dbt Cynthia repo. And as I get set up for the demo, I'm just going to show you around a little bit. So all of the SQL code for the OMOP transformation is stored in this models folder, and I have pulled up the SQL model for the drug exposure table right now. So this might seem like a pretty simple SQL query, but in fact, under the hood, it's actually incorporating data from many different sources. And I'll show you what I mean on the lineage tab here. So right now, this is showing me actually just one level of children and one level of parents for this drug exposure table. But if I expand it outwards, you can actually see there is a lot of different tables that are going into ultimately producing this drug exposure query. This is both source tables in the Cynthia database, but also intermediate tables created as part of the ETL. This visualization is auto-generated, and it's going to update automatically as things change in my ETL, and that is thanks to dbt's configuration system. So every model in the ETL has a corresponding YAML-based configuration file that looks like this, and this is the file for the drug exposure table. This allows us to both define our data model, so columns, tables, and data types, but also add tests at the table and column levels. And what you're seeing here in this YAML file, it's really the key part of my demo. So everything in this file was auto-generated by a script that we wrote, which pulls information directly from the common data model and data quality dashboard GitHub repositories. So we're not reinventing the wheel here. We're not duplicating any configuration, and we're ensuring that we're totally consistent with the OHDSI standards. So all the tests in this file correspond to actual checks in the DQD. How does this work in practice? I'm going to pull up my terminal here and say I'm a developer and I'm working on this ETL, and for whatever reason, I think that the drug exposure end date should be null. So I actually hard code that in my SQL query. And now I'm going to actually execute this portion of the ETL. And I'm going to tell it to run just the drug exposure model. And this is another cool feature of dbt. You can run any portion of ETL that you're interested in testing or working on. So I can run my whole ETL. I can run just the drug exposure table itself. I can run the drug exposure table and all of the intermediate tables that led into it. For the purpose of the demo, I'm just literally going to run this one query. And I'm targeting my dev database. So this is executing the SQL query, including my little hard-coded null. And it has run. Great. So now I'm going to run the tests, and all I have to do is change my query or my command to say dbt test, and it's going to just run the test for this model. And there's about 75 different tests defined in that YAML file. And we got 2 failures because of this change that I made. So first things first, we can see we have a failure in the not null test because, for those of you who are familiar with the OMOP common data model, the drug exposure end date is a required column in the OMOP CDM. So this is yelling at me about that. And actually, we've got a type failure because I just said null as here. It's, I think, making that column a string type. But in the CDM, our drug exposure end date column has to be a date. And I'm just going to go back to the config file so you can see how these are defined for that column. Drug exposure end date, we've got the little description from the CDM docs, and we've got 3 tests, not null. Actually, we want to make sure the column exists. And then, of course, we want the type to be a date. So now I'm going to go back and fix the error and hopefully see the test go away. If for whatever reason I wanted to keep the column null but fix that date type error, I would use one of these cast macros to make sure I'm casting to a date in a way that's going to work across many different database systems. This works a little bit like SQL render. But I want to get rid of this error altogether, so I'm just going to remove that hard-coded null and then rerun my model. So this is rerunning the SQL query, rebuilding that table without the hard-coded null. Then I'm going to rerun my tests. Beautiful, everything passed. So we got rid of those 2 failures. And of course, this was an extremely simplistic example, but hopefully that gave you an idea of how dbt test works and started to show how we might get ahead of DQD failures by integrating them directly into the ETL pipeline. I just have a couple more little slides to wrap up. I'm going to reshare those. Great. So yeah, just a quick summary of what we're going to be working on next in this project. We've got about half of the DQD check types implemented right now in dbt Cynthia, and we're going to work to implement the remaining ones. And then another thing that we're very interested in doing is adding tests on the source tables and the intermediate DBT models. So right now, DQD only runs on your final product of the ETL, the OMOP CDM. So you might have silent failures, data quality issues in those source tables that DQD just isn't able to tell you about. You might have a perfect run of DQD with no failures and yet still mess something up in your ETL that may be omitted or corrupted data coming from your source. DBT test doesn't just work on those final models. You can put them at any layer of the ETL. So we're really interested in leveraging that feature to give a holistic view of data quality throughout the entire OMOP ETL pipeline. And then finally, I think we'll share the slides afterwards. I've got links to the DBT Cynthia project. Everything I showed today is freely available in that GitHub repo. And better yet, if you are already using DBT to write your OMOP ETL and you want to incorporate these DQD tests, we've got a script that you can use to do that. So independent of this project itself, you can generate those YAML files using a script that we've got in the repo. And I will also share those links in the chat when I'm done. Thanks very much.